Hey guys, welcome to another episode of Enlear Academy. Now in this episode, I thought of discussing about processing large-scale payload with AWS step functions. So as usual, we'll discuss the theory and later do some practicals. Let's get started. Now what are large-scale workloads? Now for example, let's say that you need to batch process millions of files. So that would be a large-scale workload. And you want to process these millions of files and then send the output to another destination. Now this type of activities we can call as large-scale workload processing. So if you have a requirement to do such processing and you are always with that serverless first mind, there are like a couple of options. And there are more options really, but I pointed out two popular options most people use. Now one of the options is to use AWS Glue. Now AWS Glue is a serverless service where you can write a Glue ETL job. So the Glue job can read from, let's say, all those files and then do the processing and then write to another destination and so on. So that's one option. And also there's this step function approach. Now in AWS step function, we can use map state. So there are like various states in step function. I have a crash course about step functions. I will add a link in this video. You can watch that if you are not familiar about AWS step function. But in AWS step function, we have this map state. Now in map state, there are two modes. First one is distributed mode. The other one is inline mode. Now distributed mode is particularly built to handle this type of large workload processing. So in this episode, I'm going to discuss about this distributed map state. Now these are some of the other states: task, choice, parallel, map, wait, and there are more other steps. So here you can see the map state. Now in map state, it's all about looping through an array of items in parallel and then execute the same step or same logic for each item. So there are two types to it, two modes rather, like I mentioned, inline mode and the distributed mode. In inline mode, we can provide a JSON as an input. So to our map state, we can provide a JSON as an input, and that JSON could have an array of objects. So those objects in the array, we can process them in parallel. If you are using inline mode, you can provide the input or the payload only as a JSON input. And you can go up to 40 step function invocation in parallel. So there's a limited concurrency. You can have up to 40 concurrent step function executions. But say that your input payload is more than 256 kilobyte and you want to process that payload as fast as possible with high concurrency. So in such a case, you can use the distributed map mode. In distributed map mode, you can also pass your items to process as a JSON input. What you can do additionally is it supports S3 data source as well. So you can upload all your data item to a S3 bucket. It could be millions of items, millions of files, and point your step function to take those data from the S3 bucket and process it in high concurrency. So in distributed map mode, you can go up to 10,000 parallel invocation. Now when you compare inline mode with distributed map mode, the concurrency is really high. Now how is it able to achieve this high concurrency? Now it's because in distributed map mode, all your parallel invocations are run as child workflows. Whereas in inline mode, all the parallel invocations run in line with your parent workflow, hence the name inline. Because of that, when it comes to execution history, inline mode executions are limited by the parent history limits, which is like 25,000. And that will be a problem if you have a lot of parallel invocation and your history is not there. So you can't do like proper debugging and so on. But in contrast to inline mode, distributed mode do not have this problem because each child workflow has 25,000 history. All right, that's it for the theory. Let's get started with some practicals. Alright, so let's do a quick demo about distributed step functions. Now here, this is what I'm going to cover in this demo. So I have created a distributed step function here. So you can have as many other steps before this distributed map section and after this map section. But we are keeping it simple. I only have a map state in this step function, and that map state has another step here. Can you see that? So that's a lambda function. So as far as the maps distributed map state concerned, so what it does is we are putting a file called source.json into S3 bucket and connect that with our map state. So this is where all our data related to the processing resides. So in this case, what we are going to do is we are going to create this JSON file. It could be a JSON file, CSV file, or even multiple files or objects in S3 as well. But here we are going to use a single file approach. So there's a file called source.json, and this JSON file has 100 items, and each item includes some data to be written to the DynamoDB. So what this map does is it will read from this source file, source.json, iterate over those items, enrich it. So we have a lambda function to do that. So it will iterate over the items to be written to DynamoDB, enrich each item, and then do a batch write. Can you see that? So we are doing a batch write from the lambda function. So before doing the batch write, we are doing some enrichment. Now, we are not processing entire 100 messages at once. We are going to do it batch by batch. The distributed map read these 100 messages and send 10 by 10 to the lambda function. So we set the batch size as 10, and also I'm setting the concurrency as 3. That means at a time there will be only 3 child workflows running in parallel. So how many messages it will be ingested by those 3 step function child workflows? 30 messages. First child workflow read the 10 message and then write to that, and in the same time there will be another child workflow writing the next 10 messages and writing to the DynamoDB, and also another one writing another 10. So at a time we will be writing 30 messages using a batch write API to DynamoDB from these lambda functions, and after that it will process with the next batch. Okay, so that's what we are going to do. And also, once all this processing is completed, the results of this processing, because there could be messages that errored out, there could be runtime errors, so on and so forth, and there could be messages that are successfully written to DynamoDB. So all that information will be written to S3 bucket, and in that we are using the same S3 bucket that we put this source JSON, but we are going to create a new folder called results, or a new prefix in the S3 bucket, and that's where all these results will be pushed in. So it will say how many successful messages were there, how many failed messages were there, so on and so forth. It will be good to know what happened during this processing. Alright, so let's get started. Alright, so I'm in AWS console. I will go to step function. So let's go ahead and create a step function. Create step function. Create from blank. So I gave it a name, and I'm going to select it as a standard step function. So our parent step function is a standard one. So I'm going to go ahead and click continue. So right now I'm in the step function studio. Now on our left side, we have the actions, flows, and patterns. Now here under flows, you can see the map state. Let me drag and drop here. And now I can add additional configuration. As we have discussed, there are 2 states to the map state: inline mode and the distributed mode. We are going to use the distributed mode. Let me select that one. Also a name. You can see the change reflects here in the UI. Next, we need to set up the item source. From where is it fetching the data? Is it from S3 bucket, or is it from the step function input? So I want to use S3 bucket. So if I scroll down just a little bit, you will see these two options, state input, Amazon S3. So let's select S3 because of some limitation that we discussed in the state input. And now I have to select the S3 item source. Now when it comes to S3, we can either have list of objects in the S3 bucket, or it could be a JSON file or single JSON file in S3, or it could be a single CSV file in S3. So we are going to use JSON file in S3. And now I have to select the S3 bucket. Here I don't have S3 bucket yet. So let me select browse or enter S3 URI. Now I can go ahead and write the S3 URI. But before that, let's go ahead and create a S3 bucket. Select S3 and open that in a new tab. Go ahead and create a new S3 bucket. General purpose one. Give it a name. And I'll leave the rest of the settings as default and then create the bucket. Bucket is created, successfully created, and then I'll click view details. That will take me to the bucket. Now I'm gonna add this bucket S3 URI. It's nothing but S3:// in the bucket name in here. Alright, and it's connected now. Okay, so we connected the S3 bucket, but we also want to select the JSON file as the source, right? Because our S3 bucket right now, it doesn't have anything in the bucket. So since we are using the JSON file in S3, we have to create that source JSON file and refer it. So first, let's go ahead and upload that JSON file. Now in this demo, I'm going to use the source JSON that looks like this. So it's an object array, and in each item, we have a PK and SK. Now when you hear PK and SK, you might think there's something in relation to the DynamoDB. Yes, that's right. So what we are going to do is, we are going to insert DynamoDB item for each and every record in this JSON array. So each DynamoDB item will include a PK and SK. So PK is the partition key, SK is the sort key, and we will also add another attribute called payload, and that is nothing but some random string. But as far as the source JSON concerned, it only has this detail. By the way, this file can vary based on your data processing need, but this is for this demo. And I have 100 of these records. If I search for PK here, you can see there are 100 records. Okay, so I'm going to go ahead and upload this one to our S3 bucket. Here we go. Let me drag and drop. Scroll down, upload. It is uploaded. Now I can change my path /source.json. Alright, so we set up the S3 bucket, and now let's add some configuration on how this step function is going to process the records in the S3 bucket. So one of those configuration is the batch size. So we are going to create a lambda function here, and that's the step which will add that additional attribute and then do the batch write. Before that, we are going to read. So we are going to read 10 items by 10 items and push those 10 items to the lambda function invocation, and it will do the batch write here. So let's add this one. If I scroll down here, I can see this section item batching. I'm going to use it. And then I can set the batch size maximum items per batch. So you can define a value between these two numbers, 0 and 100 million records. So I'm going to set it as 10. Now apart from that, you can also define the max byte size per batch. So let's say you have like a large JSON file, and each JSON object is huge in size. So in such a cases, you can define the max bytes per batch. So here, if the max items per batch is also defined like 10, but the cumulative size of 10 messages is greater than this max bytes per batch, it is going to reduce the number of items. But in our case, we don't have to define it because our JSON is like a very small JSON. Now, in addition to that, you can add other attribute if necessary, because although I have symbol map state, there could be like many other steps before this one and after this one, right? So there will be like other sources where you can push some information into this batch processing. This will enable that. All right, so next is the concurrency. Now remember we discussed, we are going to set the concurrency as 3. Batch size is 10. Here it's 10. But the number of concurrency for the child workflow, in our child workflow, we only have a Lambda function, right? Because there's only one step. But the concurrency of this Lambda function can go up to 3. So each Lambda function will process 10 messages. 10 into 3 is 30 messages. And we'll be inserting into the DynamoDB using batch write from each of these Lambda function that is running in parallel. So essentially the throughput to our DynamoDB is going to be 30 messages per second. So this configuration is solely depending upon your use case. So here I set the concurrency as 3. Next, child workflow execution type. Now earlier when we were creating the step function, we selected as the standard step function, and that's the parent one, right? So the parent one could have like other steps. By the way, let me add some pass state here. So this is, let's say, a pass state called hello, and another pass state maybe after this. So now there's like a little bit of a distinction between the parent workflow and the child workflow. So this is our map state, and that will include child workflows. This is our parent workflow. So for parent workflow, we chose a standard step function. Similarly, for our child workflow, we are going to select standard workflow. Let me scroll down just a little bit, standard. Now why am I selecting standard here? Now there's a feature called redrive from error. Now that we are processing huge number of data using this distributed map batch by batch, we could see some issues during this batch processing. So in such a cases, we can instruct the distributed map state to stop all the processing and show us the error. And once we fix the error, we can redrive it from where we left off. Now this is a really cool feature. You don't have to like rerun the entire distributed map state again. But that's only supported in the standard step function mode. Next, the additional configuration. Now this is the place I'm gonna leave this as it is, because you see this option, it says set a tolerated failure threshold. What this means is, if one of the child workflow execution fails, we will still let it process the rest of the batch, because we are processing 10 by 10, right? If one batch is failing, we'll still let it process the rest of the batch. Now if I select this one, I can define some failure threshold. Let's say my failure threshold is 50%, and I have 2 child workflows running in parallel. Even if one fails, we will continue to process it because 50% is passing, the other 50% is passing, right? But in our case, I'm not going to use this setting. Here I will leave it unchecked, which is it's not tolerating any failures. So if at least one batch fails, this distributed map state fails. But we can investigate the error and then we can redrive from where we left off. Now we need to include the Lambda function here, but before that, after our processing, we can set the step function result to S3. So here I'm going to choose the same S3 bucket, the one I used here. Use the URI and then the name, and I'm going to create a folder in our S3 bucket, or a prefix rather, to keep these results. Let me call it results. That's the folder or the prefix. And then I'm going to create this folder. There you go. The folder is created. And now I will refer it. /results. We have to set up the processing step, because when you are creating the step function from UI, it's going to add all the permission necessary to run this step function. So let me go ahead and add a lambda function. So I'll search for lambda, and here I can see the lambda invoke step. Let me go ahead and drag and drop this step. I will change it to process. So this is our process step, and I'm going to select the lambda function name. I can use the ARN. So I'll first go ahead and open lambda console. You can search in the AWS console and open it in a new tab. I'll go ahead and create a new lambda function. This is the distributed map processing lambda. I will leave the rest as it is and create the lambda function. So the lambda is created, and we are going to update the code shortly. But right now I'm going to select the ARN. So this is what I need. So right now this one is just sending hello from lambda. I'll copy this ARN by clicking this, and then I'll paste it here. So my lambda function is properly connected now. And now I'm going to go ahead and click create. Here we go. It's automatically adding permission to fetch from S3 and invoke our child step function. So it needs the parent step function needs step function invoke permission again, or start execution, and AWS lambda for traceability, X-ray, and so on and so forth, right? So it's adding all these permission. I'm going to go ahead and click confirm, and it's creating my step function. Hey, hope you're enjoying the tutorial so far. I want to quickly tell you about Enlear, a technical content marketing company. We know how busy the developers are, right? So the last thing on their mind is to writing blog posts. That's where we come in. We create high quality developer focused content to keep your audience engaged and drive conversions. Curious how we can help? Schedule a call with us and let's boost your content strategy together. Now back to our tutorial. Alright, so now let's write the logic in the lambda function to read the 10 messages that is passed on to it, and then do a batch write into the DynamoDB table. So I'll click here. So this is our lambda function. Let me open that lambda function, and then I will edit the code. We have a nice editor here. So let me just clear this out, and I'm going to paste some code. Here we go. So in this code, I'm requiring the DynamoDB client so I can write to DynamoDB, and I'm doing the batch write. And then I start the DynamoDB client, DynamoDB document client, passing the client here, and then I'm ready to write to my DynamoDB table. So I'm going to create a table called DM table, and then we'll console log the event so we know what is passed down to it. And since I'm using DynamoDB batch write, I have to prepare my query in a way in this format. I have to have this put request and item, and for each item I'm adding the PK. So this item is directly coming from the S3 attribute item.pk and item.sk. So these two are directly from the S3, and this is the additional attribute that I'm going to add. So it's the payloads for now, like I'm hard coding it, hello, and then some random UUID. So based on your use case, you can do the data processing activity. It doesn't have to be writing to DynamoDB. It could be like anything, right? Anything related to your data processing activity. And here in this example, although I set the batch size to 10, I can go ahead and increase it, right, if I want. So that's the beauty of it. So I can do the configuration changes on runtime. So if I change it to 100 and so on, so I have to make sure that we are splitting the batch by 25. So DynamoDB batch can process successfully. There's a limit to batch write. You can only do by 25 by 25. So I do the batching like so. And at the end, I'm gonna run each batch and then do doc_client.send, and I'm gonna issue the batch write command. So this is my Lambda function code. I will go ahead and deploy it. I click here and there's the deploy button over there. I'll deploy it. But in order to run this, Lambda function has to have the permission to write to DynamoDB. So let's quickly add that. I'll go to configuration section. Now, before adding it, let me create the DynamoDB table, right? So I will just search for Dynamo. And in the code, I prefer the DynamoDB called dem-table. Now, earlier I have already created it. So let me go ahead and do dem-table2. And I will go ahead and create that table. And the partition key pk, and that's of string, and the sort key sk, that's of string. Default settings are fine because we are using the capacity mode on demand, which is good. And I'm gonna go ahead and create the table. So while it is being created, let me deploy it again because I changed this table to table2. Now go back to the configuration section and then go to the permissions. And here's my Lambda function IAM role that is automatically created with it. I'll go there and I'm going to add DynamoDB permission. So this role has access to CloudWatch logs and all. So I'm going to click add permission, create inline policy. Select the service, DynamoDB. I need batch write. And the table is, I'm going to add that table. So this is in US East 1 region. Table name is, I think it's already created, dem-table-2, dem-table-2. That should do it at ARN. Okay. And there are no any request conditions. I'm going to click next. DynamoDB put permission and create it. So it's created and attached to the Lambda role right now, which is good. So now I think it's all good. So all we can do is we can test our step function. So what we are expecting here is it will run this parse state and then it get to the distributed map state, and there it will pull in the S3 data and then batch it 10 by 10 and pass it to this Lambda function. This Lambda function will process that batch and then write it to this DynamoDB table, dem-table2, which right now doesn't have anything. Okay, so let's see if that works. And I'm going to go ahead and click execute here. So as the input, you don't have to pass anything because we are getting it from S3. So I'm going to go ahead and click start execution. You can see the start execution graph. By the way, if you want to see what's happening inside, you can click here in the distributed map section and then you can see each map run. You can click here, map run. And I can see my map runs are successful. Did you see it has run multiple times? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I would believe. So altogether, this is the 100 messages processed in 10 message batches. So apparently it worked correctly, and if I go ahead and refresh it, I should see the messages. You can see, look, I opened one of the messages, SPK, SK, and the payload that I have added hello and some random number. And I can see 50 messages here, and if there's another page, I think. Yeah, there you go. It's 100. Are there more? No. So there's only first page, second page. So all my 100 messages are persisted. So our step function distributed map is working as expected. One thing I also want to show you is how the Lambda concurrency worked. So I set the Lambda concurrency as 2, right? So if I go to this Lambda function and go to monitor section, Still the data is not populated. Let me choose last 15 minutes. We're gonna have to wait a little bit until these matrices are populated properly, but let me expand this, and there we go. So I can see one data point right here. So that's the side, that's the execution. You see the concurrency is 3. So the maximum concurrency that this lambda function had done, you see maximum, I have selected maximum, is 3. So there's 3 lambda function invoked in parallel. So it took the messages from this step function 10 by 10, right? And then wrote it to our DynamoDB table. So this is the way that you can handle the concurrency or the throughput to your downstream services. Although like you have millions of records here, you can handle your concurrency and make sure that you are not killing the downstream services. Now I can like increase it because DynamoDB is able to process more records than 30 messages per second, right? But I'll leave it at this right now. So I hope you get the point. And also you can test out the error condition, right? Now, for example, if I go to the code and I'm going to throw an error here, right? Here I'm going to throw new error failed. So what will happen? We'll go ahead and deploy it. That should throw an error and our step function should fail. So it's deployed and I'm going to go ahead, close this one, that one. And here I'm going to go ahead and click execute on my parent step function, start execution. Now it's running. I can click here and then I can see the map run as well. Let me check. Look at this. It failed. So while it was processing the records, you can see like it's failed 100% of the time. So what we can do here is I can go into one of this execution, child execution, and then I can see why it is failed. Cause error. Look, error of trace. So this is the error failed. So this is the message I wrote it. So if I go here, so this is the input. So this step function its execution received this input and this is the error that is thrown. Now the good thing about this is I can go back to the step function. So there's a way that I can redrive from the failures. If I go here again, so it already got 10 messages, right? It already got 10 messages into this step, but this step failed. So I can do any fixes. So this is the lambda function, right? And without starting this execution all over again, I can redrive only this fail state across all the child flows. So how can I do it? So it's easy. Now I will examine where the problem is. Then I find out, okay, there's a problem and I'll fix it and then I'll redeploy it. So here I'm removing that throw error and then redeploying it. And now I can go back to my step function. There we go. And then I can simply go ahead and click redrive from failures. Or the other option is start new execution. But if you want to process from where it left off, you can click here and then click redrive execution. Now the redrive is happening. Look, succeeded. The other, because they were failed earlier. Now if I refresh, everything is, all 4 are succeeded, and now it start processing the rest of it as well. Everything is now succeeded. So this is really useful if you don't want to process the same thing over and over again, particularly when you are processing large number of items with the distributed map. Now, in addition to that, you can also set up that threshold value I told you, right? So if you don't mind failing few execution, you can set the threshold that you are able to tolerate, and then step function execution, the distributed map will keep processing the records until it reach the threshold. It could be based out of the number of messages that is failed, or based out of some percentage. Okay, so this is what I want to show you guys. I hope you understand how distributed map works. I'll see you in another video. Thank you.